Welcome back to Chaos Lands. The last 3 episodes we created or generated this world, and today will keep going and we will generate a lava hill. You can see there are normal hills, and we also have a tile that's called lava hill, and we will replace one mountain with this lava hill. But before we start, let's clean up some code we left last time. The code for the North and South Pole looks really similarly, so let's take the code from the North Pole and put it in a function, so we don't have to keep duplicate code in our code base. The function is called placePole, and it takes a world size to make some calculations, the position where the ice should be spawned and the snow should be spawned. Remember, at the South Pole the ice should be at the bottom, and over that should be the snow, and at the North Pole there should be snow first and then ice at the top. So let's use this function to replace the code we have here. So what we want to do is just copy the position where the snow gets generated and the ice gets generated into the function we just created, and that should do the job. And do the same for the South Pole. There it is. The North Pole is still as I expect. First comes the snow and then the ice, so that works still fine. The next step is to replace one mountain with a lava mountain. This two-dimensional loop checks if any tile position is a mountain, and if it's a mountain, then all nearby tiles should be replaced by lava mountain. So how does it work? We start by the coordinate 40 because we don't want to generate this hill inside the North Pole or South Pole in this case. And if this tile is mountain, then we want to call a function we will create now. The function is called replace all nearby, and it only takes one position. At first we again check if the position is a mountain, because we will call this function recursive, and if this function, this position is a mountain, we will set the type to lava mountain. Another thing is that the mountain should be surrounded by stones, so that you can see the stones first and then the real mountain will come, so calling the function placeBiome will do this. Before proceeding, the function placeBiome has to be adjusted. The range of the biome should be custom, so that there is a parameter you can input, and therefore we create a new variable range and make the range of the function dependent of the range we insert. And because of that, we also have, for the other biomes, we have to insert the range, but that's no problem. And also insert the range for the stone, and the range for now will be 20. Also, while placing this biome, we want to override all other biomes, so we don't want to place the biome onto some other biome like we did always before. We want to override it, so there's the type invalid, and if the type invalid is inserted, we will ignore the onto type, and onto type it will be placed on every tile. So in short, if the onto type is equal to invalid, we want to place the tile of the type we inserted in this function. The next step is to replace the surrounding tiles also. So this is done by calling the function replace all nearby, and give a little bit different coordinates. So we will move one tile to the right, one to the left, one up and one down, and check if those are the type. For example, the mountain type, and if they are mountain, then they will be replaced with the lava mountain. The function transCD transforms the CT position at the given vector. So for the first vector we insert 1, 0, and this will place the position one coordinate to the right. So the x value goes one value up. The same, we want to do this for every direction. So let's do it for the y coordinate and the positive and negative x and y coordinate. By doing that, the program runs through every tile in the mountain and replaces this tile with a mountain hill. And also we want to replace the tiles with lava hills and not with just lava. Now call the function with the world size and the current position at where the mountain is. And also we have to adjust the coordinates first, because now we start in the poles and that's not a good idea. But now if we start the program, nothing happens because the program gets stuck. So there's something going on that's not nice. And let's start again in the debug mode, so the program can be stopped. Stopping the program and following the stack trace leads us directly to the cause, and the cause is that the place function, place biome function, is just too expensive in this way. So by just commenting it out, we can run it again and see that the mountains get replaced. And that's also another thing that I don't like, is that every mountain gets replaced, and that's not what I intended. I just want that one mountain gets replaced at the top of the world. So there has to be a stop condition, and if the condition is true, the loop stops. So let's do that by checking if it's not stop, and if it's stop, then the loop will break. And also we will set stop to true if the replace all nearby function got called. While moving around the map, I found the lava hill at the bottom of the world, but I want that the lava hill is at the top of the world. And also there are some tiles that don't get replaced because they don't have a nearby neighbor. So we can fix this by also replacing diagonal tiles, and that's the next steps we are going to do. So first, we don't want to start at 40, we want to start at world size.y, because that's the top of the world. And therefore we also have to negate the loop so that we run downwards instead of upwards. So decrement y every turn or every iteration, and now the lava hill is at the top. And also the position where the lava spawned should be saved for later, because there should be a boss spawn near these hills, and this position is important for later. So let's just store it in the position lava pose. And now the diagonal tiles need to be replaced. So just copy the code and pick every diagonal tile. So 1, 1, minus 1, 1, 1, 1, 1, minus 1, and minus 1, minus 1. And by doing that, we get the result we want, so that every tile gets replaced. That's near the lava hill. Now the lava hill should be surrounded with stones. And this is done by checking if the tile position modular 5 in the x and y axis is 0. So in this case we want to place the biome, and that's not that expensive as if we would place it every tile, so let's try it. The stone floor gets generated but replaces every mountain in its reach, so that's also not good. To solve this problem, a new input is needed. It's called or I call it the accept value, and every tile will be replaced except this tile type that you insert. For example, if you say I want to replace every tile but the mountain, then every tile except the mountain will get replaced. And therefore we have to check if the accept type is the type that the current tile is, and if it's not the type, then we want to place the type. Here we have to insert the accept tile, and we want to replace everything but the lava hills. So therefore we just add this input. And another thing is that we don't want to replace normal mountains as well, so we have to make it a little bit more complicated. We have to insert a vector, so multiple types that should be accepted. So let's change it a little bit, and they are the accept type. So let's remove the invalid type and just make it an empty list. And now we have to check if any type of the accept array or vector is the type of the current tile. And therefore we use the algebraic function none_of and check if any of the accept value match with the type. And we do that by using lambda. So you can imagine lambda as a function that gets called for every element in the list. So we insert the accept list, and for every element in this list we will execute the lambda, and if any lambda returns true, the value evaluates to false because we say none_of, and if any is true, then it evaluates to false. And now we also can insert multiple accept values, and we can try it again if we get the result we want. So we want a ground that has stone, and we want to have lava hills. And if we move to the top of the world, we can see, if we wait a second, that we got the result we want. And that's it for this video. And if you liked it, consider following or just comment or like this video, and let's see us in the next video. Bye.